Okay, I have a real quick, very simple concept. We know that the gravity affects how fast time flows in the human body, or in an object, or in a plant. So, for instance, if you have two twin brothers, real quick, one lives in the mountains and one in the sea level. The one with this living in the mountains will actually age quicker because of more mass. So basically, more mass, you age quicker. Your time flows a lot quicker. Uh, in this concept, anyway, um, you can use that to our advantage. Basically, if you have a centrifuge, for example, the astronauts use the same thing, centrifuge, and also the fighter pilots, to get them used to the G forces. Remember, one Earth gravity is just one Earth gravity. And for example purposes, if you're 100 pounds, one Earth gravity is 100 pounds. Two Earth gravity, or G2, 200 pounds, and G3, or three Earth gravities, is 300 pounds. So basically, the more you go up in G's, the more you multiply that with the weight of an object. Anyway, the point is the actual G-force, centrifugal force, actually acquires G-force. In other words, makes an object heavier. Point is, if you have plants, and right here and right here, as it spins, let's say you add between 10 or 15 G's, that's basically between 10 or 15 times the gravity Earth. Obviously, the mass of that plant, or if you're planting, let's say, potatoes or onions or whatever, that's more of a solid than a tomato. Tomato might actually get squashed. But if you have, like, for instance, potato or onions, then you're going to increase the velocity, how faster the time flows in that plant. So the plant's going to grow quicker than normal. Normally, if you live in a mountain, it might actually age microseconds compared to the one living in sea level. But in these cases, you're talking about more than 1 G's. Because if you live in a mountain, we're talking about microseconds, and you're dealing with 1 G of Earth plus a little more mass as a mountain, but you can't compete that with another G. So you have 2 Gs, 3 Gs, 4 Gs, and so on. In this case, let's pretend it's 15 Gs, 15 times the gravity of Earth, and you start planting vegetables or fruits and vegetables. Like I said, for example, potatoes and onions, or other vegetables and stuff, then you're going to notice they're going to grow a lot quicker, because you're affecting their velocity, how fast they grow, how fast they go through time. Because the fact is that gravity affects electrons, and normally the atoms in all living things, including humans and plants, the electrons spin at 1% the speed of light. So that's what gives us that velocity. It gives us mass, and that's what affects us, the flow of time in all living things. So if the more mass, it slows down the electrons. So by slowing down electrons, you age quicker. So that's my understanding. So basically, point is that putting groceries on your table a lot quicker can be actually easy by adjusting farming in extreme G's. So let's say you farm in a larger planet that's got 10 or 15 times the Earth's gravity. In this case, centrifugal force. You're going to have plants growing a lot quicker, because their time flow is going to be a lot quicker. So they're, instead of, for example purposes, and we don't know how fast it can actually grow, but let's pretend it grows at least 40 to 50% faster, or half, or it takes half the time of growing. So let's say you grow something and it takes you a couple months. It might take you a month or less to grow something a lot quicker. It's just for example purposes. We don't know how fast the actual would work in such a scenario. But we do know one thing for a fact is more gravity, it affects faster time. So in other words, the plant will grow faster, will age quicker. So in other words, a plant might take several months, and you cut that in half or so, or you want to cut that less time for farming. So actually, Centrifugal force may actually speed up the process of growing foods and crops. So that's the concept. So, and we won't know how fast they grow until we do experiments, but that's my invention, my concept, my idea. It's for the world, basically. Like I said, we will not know until we do experiments to see how fast they actually grow.